Hello, everyone. My name is Xiaoji Chen. I am a software engineer on the visualization team. Today, I'm here to talk about one of the public-facing projects that I did last year, Uber Movement. So if you're not familiar with it, here was the announcement video.
Cities are growing and changing, and this growth has an impact on how we get around. To help address these challenges, we are introducing a new product, Uber Movement. By leveraging anonymous GPS information from hundreds of thousands of online Uber vehicles, Uber Movement provides a new way to show how traffic is really moving around your city. Uber Movement was designed in partnership with urban planners and transportation professionals, and provides powerful tools to analyze traffic changes over time. Over days, weeks, and years, patterns emerge and help inform decisions for your city. Uber Movement offers access to the insights you need to make smart choices for your city today and tomorrow.
So a little bit of background. As a company whose mission is to make transportation more available and reliable, Uber has the data and the motivation to help cities plan their future of transportation better. So data scientists at Uber already use our data to project supply and demand, to dispatch cars more efficiently, to reduce the number of vehicles on the road by enabling Uber Pool. But we also know that these data can be so much more help if they can get into the hands of the organizations beyond this company. The problem there being from, say, Uber's legal department's perspective, there's always a risk when you share raw business data. Are we exposing personally identifiable information? Are we potentially, are those data going to be used against us in policymaking? And from the city's perspective, they lack the expertise or the experience to mine these data for insights. The sheer amount of data overwhelms them. And it's been really frustrating. We had a partnership before with, say, City of Boston, and it has proved to be a really difficult collaboration. Movement was born to bridge that gap between goodwill and positive outcome. So instead of just dumping raw business data to our partners, we're not only opening our data to them, we're also providing a tool for them to analyze the data to gain insight and get immediate value out of it. Here are three target audience or key personas that are using these. For city leaders, they are making the decisions. They make decisions about what to build and improve. And so far, they have been forced to make gut decisions, and often these decisions are very political because they do not have any data to base their arguments on. Then we have urban planners. They are planning out the city's transportation network 10 years from now, and they are relying on projections that are based on outdated, sparse measurement. These data are usually purchased from third-party commercial companies. They are very expensive, and there's no guarantee that they're accurate. And finally, we have the civic community. They are the transportation nerds. They are very passionate about finding innovative ways to change how we move around. The problem being there is no reliable data source for them to make decisions on, and they don't have any access to useful insight to help city improve. In short, for each of these three personas, the root of the problem is insufficient access to the data they need to make those decisions. Here are some examples of what we think stories we can tell from Uber's data. Using aggregated GPS locations and timestamps, we can tell how fast each street is moving, or we can tell how long it takes from point A to point B. And we can also compare those and tell the impact of commute time by time of day, lane closures, tolling, or any other policy or events that occurs over time. Also, using anonymized gyroscope sensor information collected during trips, we can tell which street surface are bumpier, are in bad condition, where there might be potholes, and those can be used to inform cities to direct their resources to fix. And looking at acceleration and intersections, we can tell where drivers tend to have above average hard brakes, and that probably means higher risk for road accidents. And as a pilot program, we are offering the travel time data set of 6 cities to the public. So from April to December 2016, I worked with a team in Seattle and with urban planners and operations staff in Boston, Seattle, Sydney, Manila, among other partners, to make sure that this is a product that we can provide immediate value. We announced movement on January 9th this year with data public accessible to a group of whitelisted users. We got overwhelmingly positive coverage from the press and really welcomed by the community. 20,000 people signed up through the website to receive updates in 24 hours. And since then, the team has been working on making more cities available to more people and slowly opening up the access through the request queue. And eventually the goal is to offer data to every city that Uber is operating in, to everybody out there that's interested in them. So I'm going to push my luck today and do a live demo. Let's start from Sydney. So for each city, we have what we call a curated view or a story mode. They provide a curated story to guide you through the tool and tell you what you can gain out of it. For example, if we go to airport travel times, what does this map tell you? It tells you if you are departing from the Sydney airport to any other parts of the city, the darker the color is, the longer the travel time is. And if you are more curious, you click on the next tab, and it tells you this is showing the travel times, average travel times through December 2016 during PM commute. And this gives you more breakdown of the data by week of day and hours of day because we limited to PM commute. That's the only thing that's there. Now let's try, say, London. What's more interesting with this, we have another mode that is a comparison mode. It takes 2 time ranges and compare the travel time through this over these 2 and tell you how the travel times has changed. And here's an example. So the Tower Bridge had a closure from October 1st to December 30th in 2016 as it undergoes maintenance. And here is comparing the travel times during that closure against the average travel time, that is the free flow that's without this event. And this color is showing you that the travel time from this departing zone to this destination is 65% longer than usual. And for the more curious users or people who are more comfortable with technical stuff, you can also create your own query. So let's go to San Francisco. And this is the travel time from downtown San Francisco to rest of the area. And let's say we want to compare the weekday AM commute with weekday PM commute. And apparently AM commute is a lot better than PM commute for some reason. And And you can also change the departing state to the airport. And you can see a different pattern there. So I'm gonna walk you through some embarrassing screenshots from the process that we used to build this product. Hopefully it will help you gain some insight into the design and decision making we went through in making this visualization. This one was one of the first prototype that I built to just for us to look at the shape of the data. It shows how long it takes to travel to different parts of Boston. And those weird shapes that you are seeing are called traffic analysis zones. They are defined by the transportation department of each state, so they're out of our hands. They're a professional thing that transportation officials work with. As you can see, it's not a super fine-grained heat map. Instead, travel times are aggregated. And it is very apparent that these shapes don't make much sense to anyone else that don't work in that field. And they are more of a distraction than anything else. You can't even tell where and what you're looking at by looking at this map. In the next iteration, we pushed the choroplasts behind the road layer. And now you can see at least the labels and the roads on top of it, and you have an idea of what city you're looking at. But it still has two problems. First, because the roads are so prominent, you can't see the boundaries of the zones anymore. It kind of lies about the resolution that we're providing. Also, coastline is usually the most recognizable feature of each city. And because all these zones are overlapped on top of the inland waterway, you can't really see that. In the next iteration, we try to provide an opacity slider to the user so they can decide to make the overlay layer more transparent so they can see what's underneath. And we quickly ditched this idea because when you do that, the colors on the map don't match the legends anymore. And it looks really silly. So here is what we have closer to what we have today. We lifted the water layer above the choroplast, so you can clearly see where the waterway is, the coastline of the shape of the land of the city. And also, because we're doing that, we are able to change the opacity of the choroplast to 100%, and it gets this lot more sharper, crisp view. Color scale design, we had a lot of back and forth on this. So not surprisingly, the range of travel time vary a lot between different time ranges and between cities. For example, in Seattle, the free flow, meaning there's zero traffic time driving from downtown Seattle to anywhere else is up to 25 minutes. But when it's raining, which is often, you will have a travel time that's up to 60 minutes. But if you look at London, driving anywhere from downtown London to the outskirts of the city regularly take 2 hours. And we made, so I resisted using dynamic color range in this case because I want to establish that visual connection between a color and a travel time. For example, if you change your query, change the time range, or switch to a different city without looking at the legend again, just looking at the shades of the color, you are able to tell that, oh, the travel time has become longer. But that decision also means that we need to pick a color range that has enough contrast, enough dynamic within any arbitrary subset of the spectrum. So it started from the leftmost one, and the middle was when the design team told us we can only have one brand color. As you can imagine, it doesn't work that well. And the right is closer to what we have today. Similarly, we have a color scale problem with the comparison mode. The reason we didn't go with that like high contrast and saturated green to red scale was because those colors have very specific established meaning in traffic planning, and they mean surface street speed from slow, from fast to slow. And eventually we settled with a color scale that still have that semantic connection with the idea of slow and fast, but the tone is a lot more neutral. So one fact about visualization is that the data never looks the way you wish it to. To protect writers' privacy and improve confidence, we establish a rule saying the travel time is not reported if we have less than n trips from zone A to zone B. And that resulted in a sparse data problem, especially when you set the time range to a very narrow window, for example, from 2 a.m. to 4 a.m. On a random Wednesday morning in San Francisco. That's what you get. And there's nothing we can do about that. And we went through all these iterations to test how we are going to communicate that information. Not too intrusive like the leftmost one, but still being honest about what we are looking for but did not find. We knew from the beginning that we want to provide some alternative non-geospatial perspective into the data. And this was some really embarrassing old exploration of the charts. Basically, we didn't have anything else. So we take everything that we're drawing on the map and sort them in a bar chart. Doesn't really tell you anything. This is something that we had a couple months into the project. And it's showing you when you are selecting a particular pair of origin and destination, it shows you the breakdown by weekday, by hour of day. And there's a nice 24/7 heat map there, which did not make into the final product because, again, the sparse data problem when you limit the data into a 1 hour window, it is more often than not available. The user experience design of the product was a interesting topic because this, in a way, arguably is the most complex or most professional oriented tool that Uber has ever released publicly. And like when we build internal visualization tools, we know that our users know more or less what they're doing. But in this case, a lot of our users are general public who are completely ignorant of general city planning concepts, or even people who work in city planning, they are not very techy. I'll just use one small example. It's a very tiny feature. We call it tooltip. Basically, you see all these colors on the map, and each color is associated with a travel time value. So you want to know what that value is. And this was the very first prototype that we built, where when you click on the zone, you'll set that you are departing from here, and the whole map updates. And when you hover over a zone, in the corner, it will show you what that value is. And what we found was because the tooltip is so far away from the cursor, a lot of users don't notice it the first time around. And when they do, they are very excited, so they want to dig in and see more, so they clicked. And suddenly their map is gone. The next version, we changed it to when you click on the map, it's just setting the destination. So it's not too disruptive. It doesn't destroy your current setup. And we moved the tooltip to the sidebar to another persistent location. Again, because your attention is divided into two parts of the screen, it is very hard to discover. And this was the first time that we tried showing the tooltip right next to the destination. It was still pretty dumb, like it covers up your selection sometimes. But we were also trying to use a cart design for the queries, so you don't have to see 30 options all at once. And in between these iterations, we introduced these walkthrough cards where we show you upfront when you're first visiting the page, several screens of what it does and explanations. That's a lot of text. In my opinion, I think there's too much information upfront out of context, but it does help raise the awareness of the features that we have. And this was what we ended up with. And you can see that we verbosely repeated the same information over and over again 4 times on the screen. Tell you here is the date range that you selected, and here is how that number is calculated. And that was the first design that actually worked in usability studies. Every user that we tested with was able to articulate, oh, I know exactly what this map is trying to tell me. And this screenshot is basically showing you how truly overwhelming the tool can be. So when you're setting the date ranges, you can do non-continuous date ranges. That's basically any combination of dates and any combination of weekdays, any combination of hours of that day. And this was actually requested by our some city planning department in our partners, and this is what they need to make their decisions. So this is a useful feature, but for a first-time user, this is apparently too much. Similarly, in download data, we have like 4 different tables for you to download, all aggregated in different ways. And this is when we decided that we need something more friendly to the average public. And this is when we introduced the curated view or the story mode. And as you can see, for each city, we have several stories showing them example queries or example stories that put a map into context. For Seattle, here is the comparison that show you how much that 520 bridge improved traffic, or how much the State Route 99 closure has impacted traffic. In Manila, the no window hours policy is where they introduced like banning vehicles off the road by the last digits of their plate. And they can now point to that map and say, this policy actually worked. So an example, curated story for Boston, showing how much the annual Boston Marathon is impacting downtown traffic. And the first time user click into it, they can see that downtown is apparently redder than the rest of the map, and they can read the context on the left. And as they explore on, they see that this map is actually generated by comparing certain date ranges. And for Boston, like that chart on the left show you how that impact in downtown actually started at 7 a.m. because the marathon starts at 8 and slowly died down till after 5. Just dive in a little bit on how the app was built. All Uber all Uber visualization applications are built on top of a React Redux architecture. And we used an framework that our team maintains called React MapGL. That is the React wrapper of Mapbox.gl. And I built some fancy little React components on top of that. The sidebar charts are built with React Viz, which is another open source framework that my team owns. React Redux, if you're not a technical person, I won't go into details, but basically React is a JavaScript library that that Facebook made, and Redux is the app state manager that's built for React. Together, they are really great in building a one-page web application that has complex states and data changes over time. React Map GL, if you ever build a geospatial visualization and you haven't tried Mapbox, you should, mapbox.com. They have a fantastic data service and a front-end framework library that you can use. They provide a very rich breadth of flexibility for you to style your map. And they're all vector tiles, so they look amazing. For the purpose of this app, React Map GL is essential for performance. So basically for Mapbox, the styling of the map is controlled by a single JSON object that describes everything, including from where the data comes from and where how many layers there are and what each layer looks like. A regular map that you see, say on Google Maps, probably have like more than 100 layers for each road, freeway, artery, minor roads, tunnel, bridge, all have their own width, have their own opacity, and they are shown or hidden on certain zoom levels. And for this app, we also added 7 to 8 of our own custom layers inserted into the regular map. To create that look that you have been seeing. The problem is each of these layers, they are dependent on certain data to be loaded or certain interaction that the user performs. And before that data becomes available, they cannot be shown. And if we just use one JSON object and ask Mapbox to reload the map, it's gonna be very painful, very slow, because that's a lot of, that's like tens of megabytes of data to reparse every time. And we use immutable.js in React Map GL to compare two map states and then call the underlying Mapbox API to only insert layer, change layer style, and remove layer for the part of the map state that changed. And that was essential to the performance of the movement product. We also did this little shared map component so we can build some reusable map experience. For example, in this one, it's showing that you can zoom out from a city into what we call world view. Each city that's available, it has a marker and labels. And if you zoom into one of them or click on one of them, it's loading the data for that city. And this was built as a reusable component, so we can reuse it for every visualization type from travel times to surface speed and heartbreaks. Also, we built into the map some nice animation features. For example, this screen capture is showing you that when you select a origin and destination pair, if either of them are out of the view, the map will automatically zoom and pan to reveal both of them. And it only do that viewport manipulation in the minimum amount, so it's less visual disruption. Some nice little React Map components that we built for this product. This one is showing a pop-up that is anchored at the destination point, but it tries to place itself to avoid covering that selection, but also always keep itself in the viewport. Draggable pins. Some users just don't want to click and they prefer dragging a pin and dropping it elsewhere. And we did this nice little HTML overlay button that allow you to move the selection by dragging it on top of the map. And we felt this was very useful, and a lot of the concepts of these components have made into the next version of React Map GL, so it will all be open sourced. So if you are interested, you can go visit movement.uber.com and sign up. I believe we are like, we have gone through most of the the queue. So probably it's gonna be available to you immediately or very soon. And also React Map GL is on GitHub. Thank you.